Okay, hello sir. So my name is Thivyavenessa Praksh and my metric number will be B0821101148. So today I would like to discuss about actuators. So this actuators is a component of a machine that produce force, torque or displacement, usually in a controlled way, when electrical, pneumatic or hydraulic input is applied on a system. So there are basic principle of actuators. So the basic principle of actuators is it can convert power source energy into a mechanical energy. So what are the example of actuators? So the example of actuators will be electrical motors, stepper motors, jack screws, and etc. So next type of actuators. So there are three main type of actuators, which will be electric, hydraulic, and pneumatic. So I will explain one by one. So electrical actuators is a device that can create movement of a load or an action requiring a force such as clamping using electrical motor to create the necessary force. So example of electrical motors will be solenoids and electromechanical relay. So I can show the picture of electromechanical relay. So this is the electromechanical relay. And okay, so next will be hydraulic actuators. So this device that is used to change fluid's pressure energy into mechanical energy. So they are normally in a cylinder shape. So they do have a piston rod, extend and retract flow pot and etc. So this will be not so. Okay. So and then the third one will be pneumatic actuators, which we're gonna explain more about it later. So it is a device that can convert the energy of compressed air or gas into a mechanical motion that regulates one or more final control elements. So it is commonly used for pistons and irrigation chambers in gasoline powered vehicle. So there are three types. There are more basic. There are several basic type of pneumatic actuators, which will be spring, piston, and rotary wave. So I can show the pictures of. This is the diagram of pneumatic actuators. So that's all from me. I'll pass to my friend Najihah.
Okay, Assalamualaikum warahmatullahi. My name is Najihah. My metric number is B0822 2210450. Okay, so now I would share my screen. What's this? In the screen. Whoop. Can you guys see my screen?
Yes.
Okay. So
yes.
Okay. Okay, so this is example of pneumatic actuators. So this one is a single acting cylinder, and then this one is double acting cylinder. So it is called single acting cylinder because there's like one input to it, this one input, and then double acting because there's like two input for the air to flow lah. So for this one, we use compressed air. We can see the source here is compressed air, and this one also are using compressed air. And then we can also, okay, so how it works actually, there's like spring return for the single acting cylinder. It's like this. So when we switch on, okay, sorry, let me run this first. Sorry, okay. Okay. Yes. So yeah. So this when we feed the the piston with air, the cylinder with air, and it will retract, extend. It will extend. The piston will extend, and then if we release the air will be released into the exhaust, and the air will be released, and the spring will retract the piston. So that's the principle for this lah, for single acting cylinder. For double acting cylinder, the difference is both of the contract and retract both need the usage of pneumatic air lah. Okay, so for this, as you can see, let me switch this on. Okay, this the blue line, the dark blue line is the what is called high pressure air, and then the light blue one is light pressure, low pressure. So the high pressure will extend the piston, and then this side is now low pressure. So when it's low pressure, then the piston, the piston will extend. So if we click here, now the air pressure will go to the right side of the piston, which will retract the contract the piston. Yeah. So okay, this is called exhaust, and then this is switch. We can get from here, yeah. The valve and switches all are here from the pneumatic. Okay, so basically, I think it's the hydraulic also have the same system, the same principle, but it just the difference is what drives the piston. Because for now we use compressed air. For hydraulic, usually we use fluid. So yeah, there's a lot more other features that we can use actually to design these pneumatic things. So I will give this to Hakim. Hakim will explain more about how to control the piston better.
Thank you, Khairun, Najihah, Binti, Murad. Okay, I share the screen first. You can see, like, you guys can see or not? Hello?
Yes, can.
Okay, for the part of how to slow the flow of air or gas. So, and the first one is we gonna put one-way flow control valve, and this is the one-way flow control valve. So the function one-way flow control valve is type of valve that allows fluid and gas or gas to flow its only one direction. It's like a gate that open to let the fluid through in one direction, but close to prevent it from flowing back. It's commonly used in plumbing system or hydraulic system to control the direction of flow. So as you can see how it's work, if I put this trigger, so one-way flow spring is help to control the speed of the cylinder extension. Is restrict the flow of air going into the cylinder, allow for a control and slower extension. This can be useful when you want to precise and gradually movement. So, however, during the retraction phase, the valve allow to air to flow freely, allowing the spring to quickly return from the piston to original position. So this is the spring that I just mentioned. So if we put the trigger, it will be the piston will go out fast, and when we when we put the trigger, so the spring will come back to the original position. So this is the one-way flow control valve at double acting cylinder. So as I mentioned before, this is the single acting cylinder. So how it's work in double acting cylinder, the one-way flow control valve helps control the speed of both the extension and retraction of the cylinders. It has separate adjustment for the flow of air in both directions. By adjusting the valve, you can control the speed at which the cylinder move in each direction. It's allowed to precise and control movement in both extension and retraction. So as you can see, it's not um, it doesn't have a spring at all. It's just a two-way direction uh, extraction and retraction air pressure. So for the third one is we just gonna exchange one-way flow control valve into a quick exhaust valve. So the function of squeeze exhaust valve in pneumatic system is like a high-speed air release valve. It's designed to rapidly exhaust the compressed air from the cylinders, allowing for faster piston retractions. This help speed up the movement of pneumatic actuator, making them more efficient. So as you can see, it's like a bypass, and the air go through this exhaust and not this exhaust. Mm, so how it's work and at the double acting cylinders. So when it come to the quick exhaust valve, it works in conjunction with the one-way flow control valve, while the one-way flow control valve control the speed of the cylinders. The quick exhaust valve helps with the rapid release of compressed air during the retraction phase. It's allowed to air to escape quickly, allowing to the piston retract faster. So Uh, that's all for the one ways flow control valve and quick exhaust valve. So that's another method that we can use to make the flow air slow. So first we can drag the tube of this more longer. So the flow so when it when so the piston move more slowly and have more delay from the original situation. So that's all for me. Thank you.
Okay,